Hi, I'm Ashley, and today I'm going to be talking a little bit about what I believe is causing the recent coho salmon deaths we've seen locally. So a little bit of background about what's been going on. So every fall we've been seeing about 50 to 100% of the salmon in our stream dying before they even get a chance to spawn. And we've been noticing these symptoms and deaths start happening shortly after rainfall. Because of this, I believe the salmon are dying due to something called urban runoff mortality syndrome, or ERMS. The symptoms that our salmon are showing that are consistent with ERMS are going to be swimming in circles on the surface, fin splaying, showing signs of confusion and disorientation, being hypoxic, and being unable to regulate the ions in their blood plasma. And unfortunately, our salmon are dying only a few short hours after being exposed to the urban runoff. So what is causing this? I believe these deaths are caused by something called 6-ppd quinone. Now this is a chemical all around the country being linked to deaths in coho salmon. It's going to have 18 carbons, 22 hydrogens, and 2 nitrogens. And it's got a quinone functional group. Now, chemicals with a quinone functional group have a 6-carbon ring with either 2 adjacent carbonyl groups or 2 carbonyl groups separated by double bonded carbons. Carbonyl group, as a little refresher, is just going to be an oxygen double bonded to a carbon. So in our lovely picture of 6-ppd quinone, we see our 2 carbonyl groups and they are separated by the double bonded carbons. So what is this and how is it getting into our water? So 6-ppd quinone is a breakdown product of something called 6-ppd. And 6-ppd is commonly used in tires as a protection mechanism. So when cars are driving, their tires are going to be reacting with ozone. And without 6-ppd, the ozone is going to immediately start reacting with and breaking down the rubber in the tires, causing the tires to wear out faster. But when there is 6-ppd, the ozone is going to react with that burst, protecting the rubber. Unfortunately, when the ozone reacts with a 6-ppd, it's going to break it down into 6-ppd quinone, which is going to be left on the street in the form of tire dust. So, when it rains, all of that 6-ppd infused tire dust is going to be washed into the nearby waterways. So how do we go from having 6-ppd quinone in our waterways to having dead salmon? So what I hypothesize is that when there are salmon in this 6-ppd quinone infested water, when the water is going to wash over the salmon's gills, in addition to absorbing oxygen, the capillaries in the gills are also going to absorb the 6-ppd quinone. I believe this because with the dead fish, we've been noticing a lot of damage in the gills. Specifically, the capillaries have increased permeability, causing plasma to actually leak out of the gills. So how does this hurt our fish? So quinone chemicals are something called redox active chemicals. And redox active chemicals can easily produce these molecules called reactive oxygen species, or ROSs. ROSs include molecules like hydrogen peroxide, superoxide, and hydroxyl. Now, the thing about ROSs is they are essential to this really important bodily function called redox signaling. Redox signaling is utilized by almost all cells and is really important in communication and also in activating proteins to create cascades. Specifically, a really common redox signaling process is something called cysteine oxidation. So cysteine is a residue in lots of proteins, and when it becomes oxidized, what's happening is hydrogen peroxide is oxidizing the cysteine into something called cysteine sulfenic acid. Then this cysteine sulfenic acid is able to create disulfide bonds between 2 proteins. And the really cool thing about this is this cysteine sulfenic acid can then be reduced back into cysteine. So why this process is so important is because disulfide bonds can protect proteins from denaturing, but also when these disulfide bonds are being formed between proteins, it is changing the structure of the proteins, which changes their functions. So an example of this is with an enzyme called kinase. When the disulfide bonds are formed, it is going to activate this protein, this enzyme. And this enzyme is really important in the cardiac system, and we will get back to that later. So what is happening with the 6-PPD quinone is something called hyperoxidation. So this is when there are too high levels of ROSs, because ROSs are naturally produced in our body, but when something like 6-PPD quinone comes into our body with bringing in extra ROSs, it is going to cause hyperoxidation. So back to our example with cysteine, if cysteine gets hyperoxidized, it is going to turn into sulfinic or sulfonic acid. And the issue with these two acids is, unlike the cysteine sulfenic acid, these two cannot create double bonds, and additionally, they cannot be reduced back into cysteine. So now enzymes like kinase that need cysteine sulfenic acid to form disulfide bonds to become activated, once it becomes overoxidized into sulfenic acid or sulfonic acid, these proteins become non-functional. So how does this kill our fish? Bringing it all back, we're going to be talking about something called the blood-brain barrier. It is what is going to protect our brain from a bunch of chemicals just flooding in and destroying our brain. So redox signaling specifically is very important in regulating vessel permeability. And the blood-brain barrier is one big semi-permeable membrane. So it allows certain things to come in and come out. And this selective transport of the blood-brain barrier requires a lot of energy. So there is going to be a lot of mitochondria around this blood-brain barrier. Mitochondria is going to be the organelle that is going to naturally produce our ROSs. So we know that around the blood-brain barrier, there's already a very high level of ROSs, which makes the blood-brain barrier really vulnerable when they're to hyperoxidation, because there are already so many ROSs that when 6-PPD quinone brings more in, it is just very vulnerable. And what ends up happening is the ROSs are going to cause the blood-brain barrier to become permeable, which is just going to allow unregulated chemicals to just enter the nervous system and completely overwhelm it, which is going to eventually cause the death in our salmon. Thank you. I hope that you have learned a lot about this and we can start trying to find solutions to save our salmon. I've also passed out some handouts about 6-PPD quinone and also about redox signaling to add some more information, and I hope this has been really helpful. Here are all of my references. Thank you for your time.